I'm excited you're in class. Today we'll talk about set theory, just like you had in your schedule. Set theory. But before we go deeper into what set is, let us take a little while to give some basic definitions about set. We said set is the collection of well-defined objects, and I want you to place emphasis on the fact that set is the collection of well-defined, that is, the components that makes up a set, which is called elements. Some texts call the components items. So the items or the elements of a particular set must have similar characteristics, and those characteristics must be well defined. Let us take, for instance, the set of all male students in a particular secondary school called Immaculate Comprehensive College. The set of all the male students in Immaculate Comprehensive College is an example of a set. Why? Because the items or the elements of this particular set has a well-defined characteristics. Okay, so that is why we say this type of, or this example of set is a set. Okay, now another example we have over here is the set of all the staffs of awoko.ng. Let's say the set is represented using the symbol P, and I want you to take note that sets are represented using uppercase letters, while most times the elements are represented using lower case letters. Let's say elements like Q, R, and so on and so forth. So we use lowercase letters for the elements of a particular set. So the set of all the staffs of Awoko. If you are not a staff of Awoko, then you are not supposed to be among the set. That is, the condition for a member to be called to be listed among the set is that he or she must be a staff in Awoko. Is that okay? So that is all you need to know about the basics of set as the collection of well-defined objects. Now, taking a step further, we're going to look at some problems. The reason why I just delve into solving problems is because we already have courses on sets on the platform. So you can visit the platform for a detailed explanation of the various examples of sets. Okay, so problems in set. The first problem I will consider will be taken after this subtopic, which is the types of sets. I will just do a run through of the basic type of sets that we have. We have the universal set, which is seen as the mother of all sets because all other sets can be found in it. Usually we represent universal sets using the symbol U or E, as the case may be. So we have universal set as one of the types of set. We also have a particular set called subset. Subsets are the smaller sets that can be found in a particular set. And this particular set is usually a bigger set. The bigger set is called superset. We also have a type of set called single set. We classify sets based on the type of the items that can be found or the elements contained in a particular set. So just like the name implies, single set. A single set is a set that contains just only one member or element. Another set is the empty or null set. Empty or null set. And an empty set is a set that does not contain any element at all. we use this symbol to denote an empty set, or you can decide to use this symbol as well. Having said that, I have a the sets. Sets are sets that contains a definite amount of elements or members. That is, the members could be exhausted by counting. For instance, let's say we have 1,000 staffs in Awoko. So far we can exhaust the number of staffs, then that particular set is called a finite set. And if you have a finite set, definitely we can have a set called infinite. Infinite set. Infinite set. Some persons call it non-finite. They are still the same thing, but I prefer to use infinite set as the case may be. Let us consider. I said I will just do a run through of the types of sets. We have what we call the cardinality of set. And what is the cardinality of set? It's just simply the number of elements that can be found in a particular set. So if a set contains 3 elements, A, B, and C, then we say, let's say we have P, set P to contain the elements A, B, and C. Then we can say that the cardinality of this set is simply 3, because we have 3 elements in the set. Having said that, we can also have equal sets. And equal sets, when we talk about equal sets, then we are comparing 2 or more sets together. Let's say set A compared to set B. If the set A has the same elements as set B, then we say set A and B are equal. But if we are comparing the number of elements in 2 or more sets, let's say set A containing 5 elements and set B containing 5 elements as well, then we say that both elements are equivalent. Equivalent sets. So I'm sure with this we have a broader understanding of the types of sets that we have. So this will take us to the next concept that we're going to discuss, which are the basic operations in set. What are the basic operations in set? The first one I would like you to know is the intersection of sets. So we have set A and containing elements. Set A contains elements A, B, and C. Then set B contains elements E, B, C. So the intersection of this set is simply, of these two sets, is simply the common element contained in set A and set B. And if you look closely, you realize that the only element that is common to both of them is element C. Therefore, A intersection B as is equal to the. So I will consider another, which is the union of sets. The union of set is simply the combination of the elements in one set and the elements in the other set. Let us still consider set A and set B above. Set A contains elements A, B, C, while set B contains elements E, B, C. So if I combine the elements of set A and the element of set B together without any repetition, take note, without any repetition, then I would say that I've just done the union of the two sets. So union of two sets, A union B, which is designated with this symbol U, is designated with the symbol, is not totally U, but a curved n. It's just like the inverse of the intersection. Intersection is this, while union is this. Okay, so if I have A union B, I would have to combine the two elements in the two sets A and B together without repetition. So I have A, B, C, and E. Instead of having A, B, B, C, E, on the contrary, because B appears twice and C also appears twice. So I will just have to pick one of them and include in the list of the elements that we have for A union B. So having said that, let us consider another basic operation, which is the difference of two sets. The difference of two sets. So we have, let's say we have, the difference. Let's say we have set A to be equal to A, B, C, set B to be equal to C, E, B. And I'm asked to find the difference between set A and B. The difference between set A and B is simply the elements that is peculiar, or the elements that are peculiar to set A alone. I'll take that again. The elements that are peculiar to set A alone, that is, elements that are contained in A alone. So it is denoted with this symbol, just a slash, or a minus sign. So A slash B is simply the element contained in A alone, which of course is element A. So A difference B is A. We can also find B difference A. B difference A. So B difference A will be seen as the elements that are contained in B alone relative to A. And if we want to do that, of course, the elements are or is E, as we have only one element there. And this type of set is called a single set because it only contains just one element or member. So having said that, I would also like us to consider a particular operation in set which is called the complement of set. It's simply comparing a particular set to the universal set. The difference of set that we just concluded was talking about comparing two sets, but complement compares a particular set to the universal set. So if you have the universal set to be equal to 1, 2, 3, all the way through 10, and we have a set A to be equal to 1, 5, 7. Of course, if I relate set A to the universal set, I'll have a complement. It is designated or denoted by a small bar on top of the particular set you're talking about, or A with small c on top as an exponent. So this is the list of elements that are not in the particular set we are talking about, which is set A, but are contained in set universal, or the universal set. Okay, and the list of the elements are simply 2, 4, 6, 8, 9, and 10 inclusive. Okay, so having said this will now take us to the problems in set.